Hello, am I audible? Okay, thank you. Okay, we'll start after 5 minutes. Let's everyone join. Good evening, everyone. I am Riya Tapwal. I am doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. Today, we are going to discuss the topics of week 7, and after that, we will discuss some questions related to the same week. So, last week we have discussed about Python language and Raspberry Pi. So, we will continue with that topic only. So, at last we discussed that how different sensors can be integrated with Raspberry Pi. We have integrated your DHT sensor with Raspberry Pi. So we will continue with that topic only. So once you integrate your sensor with your Raspberry Pi, you also need to collect the data so that you can analyze the data, and further on the basis of that data which is collected, you can make the decisions. So for that you need data logging. So in today we will discuss that how you are going to integrate your sensors with your Raspberry Pi, and further connect your this client side, that is your Raspberry Pi side, with your server, where the collection of data will be done, and further on the basis of that collected data some analysis can be performed. So in order to create an interactive environment, we are going to collect the data from the devices in the network and then send the same data to the server or remote machine, and control the network remotely. So what we are going to do is, we are going to integrate your DHT sensor with your Raspberry Pi. That thing will act as your client side, and once this client is formed, that your Raspberry Pi is going to collect the data from your sensor, we are going to send this data to the server. So server can be your any PC, or it can be Google Cloud also. So depending upon your requirement, you can select your own server. So today we will learn that how we can send this data from the client to the server using the socket programming, and further on the server side how we can perform various analysis and the visualization of data which is collected. So the requirements for this setup is a DHT sensor and a resistor of 4.7 kilo ohm, then jumper wires and Raspberry Pi. Now this is the overview of your DHT sensor. We have already discussed that your DHT sensor is digital humidity and temperature sensor with which have 4 pins, that is pin 1, 2, 3, 4. Pin 1 is responsible for power supply. Pin 2 is responsible for your data, pin 3 is null, and pin 4 is ground pin. This thing we have already discussed, that what are the functions of different pins of your DHT sensors. So now the connections. So first of all we have to connect the pin 1 of your DHT sensor, that is the input pin which is going to provide voltage to your DHT sensor, with your 3.3 volt pin of your Raspberry Pi. Then connect the pin 2 of your DHT sensor to any of the input pins of the Raspberry Pi. For example, here we have considered pin 11. You can take other pin also. After that, connect the pin 4 of your DHT sensor to the ground pin of the Raspberry Pi. Now once this connection is done, you have to write a program. We have already discussed that how to write a program on Raspberry Pi so that that program can read the or can collect the data from your sensor to your Raspberry Pi. So this is a program for reading the data from your sensor to your Raspberry Pi. In order to do that, Adafruit underscore DHT is the library which you can use, and Adafruit DHT.read underscore retry is the function which you can use in order to read the data from your sensor. So basically this is the program. You can use this program. This program is going to collect the data from your sensor to your Raspberry Pi only. This is not going to send the data to your server. This is the program which will work on the client side only. It only collect the data from your sensor to your Raspberry Pi. Now once this collection is done, we need to send the data to your server. So for that we need to use socket programming. So we have already discussed about socket programming, that in case of your socket programming we have to create one client and one server. So client we have already created. Your Raspberry Pi is, will act as a client. Now we need to create a server. So you can take your PC as a server, and once your client and server are created, you have to do the socket programming so that you have to make the connection between your client and server. And once the connection is established between your client and server using socket programming, you can transfer the data from your Raspberry Pi to that particular server. So basically in case of your socket programming, you have to create a two-way communication between the two nodes in the network. So here in this case the two nodes will be your Raspberry Pi and your system. The nodes are termed as server and client. Server perform the task or a service which is requested by the client. So whenever your client, that is your Raspberry Pi, is going to send the data to your server will perform some task. For example, the analysis of data, or for example in this case your DHT sensor is used. So if the temperature value exceeds then a particular threshold value, then your server is going to perform a particular task, for example to turn on the fan or something like that. Now in order to send the data to your server, you have to use network protocols. For that you have to create server and client. Then you need to establish the connection between the server and client, and then send the data from the client to the server. So in order to create a in order to create socket programming or use socket programming, you have to create socket, as we have discussed in our previous lecture. So in order to create a socket descriptor, socket function can be used. So in case of your socket function, three parameters are used. First one is your socket family, second is your socket type, and third is your protocol. So for socket family, in case of your socket family, you can use AF Unix or AF INET. Socket type can be your sock stream or sock dgram. Sock stream is used to establish the TCP connection. However, sock dgram can be used to establish the UDP connection. And by default, the value of protocol is set to 0, because we are just going to use IP protocol. So that's why the protocol is set to by default it is set as 0. Yeah. Hello. Can you please repeat what you have just said? Okay, wait. Okay, yeah, I got it. Wait. Hello, am I audible now? Okay, and is my screen visible? Can you please confirm whether my screen? Okay, thank you. Okay, so we were discussing that how your data can be sent from your client side to your server side. So client will act as your Raspberry Pi, and server can be your Google Cloud as well as your PC, depending upon the requirement. You can select the server, and by using the socket programming, you can send the data from your client side to the server, and at the server side you can perform various analysis tasks, right? Now the second thing that is required is to visualize the data. Since we have collected the data, so in order to visualize the data properly, we need to plot the data, right? So for plotting the data, first of all, we need to read the data properly, and after that, once this thing is done, we need to plot the data, so that the data which is collected, that can be visualized properly. Okay, so in order to do that, first of all, we need to split the data, because data can be connected with each other with the help of various symbols, for example commas, hash values, anything. So we need to properly, in order to read the data, we need to remove those symbols. So for that, we need to perform the data splitting. So for example here, so data from the client can be saved in a text file or a CSV file, right? And that data can be separated out by with the help of comma or other symbols also. So we need to separate out the data, or we need to separate out those particular symbols from the data, so that we can visualize the data properly. So a split function can be used to split the string into multiple string, depending upon the type of the separator or delimiter specified. So for example, here in this case, data is Sunday, Monday, Tuesday, and here the splitter is comma. So we need to remove this comma from here. So we can use a split function, and so the way is a data dot split, and inside that split function you have to mention the separator. So with the help of this, you can see that we have splitted the string into various substrings. So in order to visualize the data properly, we need to properly read the data. So for that, data splitting and filtering of data is required. Now the plotting of data. sorry. So in Python there is a library called matplotlib. So that can be used in order to plot the data in 2 dimensions. In order to plot the data, plot function is there which is used to plot the values. So inside the plot function you have to specify the value of x and y coordinates, and this function is going to plot the values of your x and y. Now if you want to put the labels also, you can use x label for x-axis and y label for y-axis. For example, here x label, inside your x label function we have written x-axis, so you can write anything whatever you want to write. Okay, so this is the way you can put the axis in your plot. So and if you want to give title to your plot, you can use title function. So this function will add title to your plot. Now for example, first of all you have to import the library matplotlib. After that, here my plot you are using plot function in order to plot this value 1 2 3 4. So by default these values are for y-axis, and x values are taken automatically starting from 0. So by default the x values are taken starting from 0, and if you don't want that, you can separately mention the value of x and y in the arrays, and that can plot the these values over your plot. Now I'll show you one example also. Wait. So here in this example, first of all I have imported some libraries, for example pandas, numpy, matplotlib, because these library I need these libraries later in my program, but here I just want to show you that how this plot function can be used. So first of all, here I have read the CSV file, that is your sensors1.csv, and I have stored the values of different columns of this CSV files into your different arrays. For example, x, p, q, r. I have appended the values of these columns into these arrays, and once this is done, this is just reading the data. If you don't want to do like this, you can manually put the values of different arrays here. So basically I just want to show you this thing. So first of all you have to import the matplotlib library. After that, here I have specified the font type, and the font type which I want to mention for this labels, that is this stock value or this 5, 10, 15, all those things. So in order to specify the font type which I want to use in my plots, I have done this here. So font 2, I have specified the family will be serif, then the font weight will be bold, and size will be 16. Now the label of y will be torque, as you have seen that for y-axis it's torque, and for x-axis it's time, right? Now I have used for loop in order to mention these labels, that is 5, 10, 15. So for each label I want the font size to be 40, it should be bold, and for the family should be serif. So for all the ticks I have used this for loop, and after that in order to put the grids into your plot, I have used grid function. The layout should be tight. Now I want to plot the x and y, right? So x and y I have read from your sensors.csv and appended those in your x and y arrays. right? So I need to plot those values, and this is the marker type. For example, here P means this pentagon shape. Here you can see that for each data type I have used pentagon shape, right? So that's why I have put the marker type as P. Marker edge color should be red. As you can see, the color is red. So you can make changes in your plot accordingly. So you have to mention all those things, and accordingly you can plot your data. Now for example, here what I have done is for your y I have put the limits also. So y can be when y can vary, the points of y can vary from 1 to 25, right? You can change those values also. And in order to further save this figure, whatever plot is generated, you can use plt.savefig. So you can use different functions depending upon the need, right? So you can make changes accordingly. Whatever you want to do, you can make changes accordingly to your plots just by importing the matplot library. And further, the various functions are there in this library. You can use those functions, and accordingly whatever you want to do with your plots, you can do. Now these are the some function which you can use while plotting. So first one is figure. So it is used to create new figures. Second is grid. So it enables or disable axis grid in your plot. I have shown you that how to use grid function. Next one is iron. So it turns on the interactive mode. Next is subplot. It adds subplots in your figure. Then close. It will close the current window. And then scatter. So in order to make the scatter plot, you can use scatter function. Now the next topic is your software defined networking, that is your SDN. So consider this first figure. So here this is showing the current network scenario where user 1 is connected to your user 2 with the help of different routers or different gateways. Okay, so if your user 1 want to send data to your user 2, it can follow different paths. For example, it can follow this path also, it can follow this path also. So there are various paths between your user 1 and user 2. So depending upon the algorithm which you have used, the path will be decided. For example, if you are using Dijkstra algorithm, then the shortest path between your user 1 and user 2 will be selected. So for example, in your this case, OSPF protocol is used. So the path which is selected is this, which is shown with the help of red color. Now consider a case when this switch has been attacked. Now if this switch has been attacked, it means this path is broken now, this path is corrupted. Now if user 1 wants to send data to user 2, it has to follow some different path, right? So in order to do that, we have to make changes into the current network. So there are different switches present in the network, so you have to make changes in all those switches, right? So that this path will not be followed and some other path will be followed. Now the limitations of the current network. So the current in case of your current network, the vendor specific architecture of switches limits the dynamic configuration according to the application specific requirement. The switches are required to configure according to the installed operating system, and the centralized control in this case is not feasible because different switches have different configuration, right? So it is difficult to place some centralized control in that case. Now what is required is because in this scenario, if a particular switch get corrupted or attacked, then we need to make changes in all the other switches. So this process is cost expensive because we have to write the code in each and every switch which is present in the network, so that that particular route will not be followed, right? So we have to make changes in your millions of gates. You have to make the changes. You have to make changes in the codes also. So this is very cost expensive process, right? So the solution for this is to separate out the hardware part from your operating system and application part, and better to put the application and operating system part as a centralized controller thing. Because if some attack will happen on your hardware part, then you don't need to make changes over different nodes. You just have to make changes at a particular centralized node which is going to control the complete network, right? So this is the main idea behind your software defined networking. So what software defined networking is, it is going to separate out your hardware part from your operating system and application part, and make this operating system and application part as a centralized thing. So this is your current network scenario where software defined networking can be used. So in this case, your hardware is separated out from your operating system and your application part. Now, depending upon the application or depending upon the requirement, the centralized control or the placement of your application and your operating system can be centralized, or it can be distributed. For example, in this figure, for each of the switch there is different application and operating system. However, in other scenario it can be centralized only. So for different for these different hardware, there can be one operating system and application which is going to control the complete network. So it depends upon your network scenario or the application where you want to use this SDN. Now the second figure, this packet forwarding hardware is separated out from your operating system, which is centralized, as I have told you already that operating system can be centralized. So here there is only single operating system and different application depend which can use those operating system and hardware. Now the origin of your software defined networking. So in 2006 at Stanford University, a team proposes a clean slate security architecture, that is SANE, to control the security policy in a centralized manner instead of doing it at edges. In 2008, the idea of software defined networking is originated from OpenFlow project, which is published in ACM SIGCOMM in 2008. Then in 2009, Stanford publishes OpenFlow version 1.0.0. This is the specialization of this OpenFlow protocol. And in June 2009, Nikera Network was founded. Then in March 2011, Open Networking Foundation is formed, and finally in October 2011, first Open Networking Summit was published, and many industries such as your Juniper, Cisco announced to incorporate with this. So finally in October 2011, your software defined networking is used by different industries. So this is the architecture of your this is the SDN architecture, where your data plane, that is your hardware, is separated out from your control plane and your application plane. Now in case of your SDN, we separate the control logic from the hardware switches, define the control logic in a centralized manner to prevent the multiple modification in the network in case of your hardware is corrupted. It controls the entire network including the individual switches. So this centralized controller is going to control the entire network. and the communication between the application control and data planes are taken place with the help of APIs. So we will discuss these APIs later. Now the current status of SDN. Companies such as Google have started to implement SDN at their data center networks. It is required to change the current network with SDN in a phased manner. The operational cost and delay caused due to link failure can be significantly minimized, because since we don't need to make changes in all the nodes, right? So this is going to reduce the operational cost also and the delay also, because we have to make the changes at the centralized controller only in case if a particular node get corrupted. So this is going to reduce the delay as well as the operational cost. Now the components and attributes of your SDN. So the components are hardware switches, controller, applications, flow rules and APIs. Now the hardware switches are placed in the data planes, which is going to forward the data from from the sender to the receiver. The controller is the operating system thing which is going to control your different hardwares which are forwarding the data, and the application are the different applications that are using those switches and controller. The flow rules are the rules which will decide that how your data will be flowed from your sender to receiver. And then the APIs. So APIs are the interfaces between your hardware switches and controller and applications, and different controllers also. So we will discuss these APIs later. Now the challenges that are there in your SDN. So first one is your rule placement and second one is your controller placement. Now what do you mean by rule placement? Since I have discussed that flow rules means the rules which will decide that how data will be flowed, right? So the problem is, or the challenge is, that which rules we need to place, or which rules we need to store at the controller, because the memory which is used at the controller is TCAM, and it is very expensive, and the memory which is available is very less, so we cannot store a large amount of rules in that memory. So we have to store only few rules, and that those rules should be like that. So all the data or all the flow which is coming from the nodes, so that data can use those rules and can transmit that to a particular sender. Okay. So and the second one is controller placement. So controller placement means that where exactly we need to place the controller, so that the overall delay in order to exchange the rules should be less. Okay, so first is your rule placement. So your switches forward the traffic based on the rule, that is your flow rule defined by the centralized controller. So traditionally in your computer networks, routing table are maintained by different routers which are available in your network, right? And based on those routing table or the information which is stored in those routing table, the data will be flowed. So your flow rules are similar to, or this flow table is similar to your routing table. So flow table also maintains flow rules which will decide that how your data will be flowed from your sender to your receiver. So the entry which is there in the flow table is called your flow rule. Now each rule has a specific format which is also defined by a protocol which is called open flow. So we will discuss about open flow later. So this is the example of your flow table which show that so in your flow table different fields are there. For example, priority, ingress port, MAC source address, MAC destination, then protocol IDs, IP source address, IP destination, source port, destination port, instruction. So depending upon the rule, different fields can be filled, and on the basis of these fields the data can be flowed from your sender to your receiver. Now the challenge of your rule placement. So, as I have told you that the memory which is used is your TCAM, that is your ternary content addressable memory. This memory is used at your switches. So at different switches your flow tables are maintained, which is going to store your flow rules, and the memory which or the size of the memory of this TCAM is very less or limited, so you cannot store large amount of rules at your switches, right? So the challenge is which rule we need to store at the switches and which rules should be there in the controller. So this is similar to your cache memory and main memory. So there also it is a problem that which data we need to store at the cache memory and which data should be present in the main memory. And the challenge is that the data which is required by the user most, we need to store that data in the cache memory, right? So similar to that case only, the flow rules which are required more or which are used more by your data should be stored at your switches, right? So now the challenge is what are the different rules that can be stored at the switches. So that is the first challenge. Okay, so on receiving a request for which no rule flow is present in the switch sends the packet message to the controller. The controller decides a suitable flow rule for the request. The flow rule is inserted at the switch, and typically 3 to 5 millisecond delay is involved in order to place a new rule. So similar to your cache memory, so whenever a particular rule is not present at your switch, then a packet in message is sent to your controller, and then whenever your controller will receive the packet in message, it will decide the most appropriate or most suitable rule, and it will send that particular rule to your switch, and the whole process will take around 3 to 5 millisecond of delay, right? Now the challenge which is there is to select the most suitable flow rule, so that the exchange of these packet in message and flow rule should be less. So this is the challenge, that how to define and place the rules at the switches while considering the available TCAM. How to define rules so that less number of packet in messages are sent to the controller. So for rule placement, two challenges are there, right? That how to define the rules, first challenge is that, and second is how to place the rules at your switches, so that the exchange of messages, that is your packet in messages, should be minimum. Now open flow protocol. So this is the protocol available for rule placement. It has different versions, for example version 1, 1.1, 1.2, 1.3 and others also, and for these different versions of this open flow protocol, different fields are there in your flow table. For example, here in different fields are different fields can be your source IP, destination IPs, source port, priority, or others also. For example, your ingress port, your ID, then your instructions. So depending upon these values, it is decided that how your data should be flow from your sender to your receiver. Now how much time a flow rule is to be kept at a particular switch. So in order to decide that, two timeouts are used in your open flow protocol. First one is your hard timeout and second one is your soft timeout. So in case of your hard timeout, all the rules are deleted from the switch whenever your hard timeout occur. This can be used in order to reset the switch. So whenever a hard timeout will occur, all the rules will be deleted and new rules are placed at your switch. And in case of your soft timeout, if no flow rule received associated if no flow is received associated with a particular rule, then after a particular amount of time, that is your soft timeout, that rule will be deleted from the flow table. This is used to empty the rule space by deleting the unused rule. So basically this soft timeout is used to delete the rules which are not used for a long time. However, your hard timeout will be used to your reset the switch. Now there is one myth that SDN is a open flow. So basically SDN is not an open flow. SDN is a technology or concept, and open flow is a protocol which is used in SDN in order to communicate between the data plane and the control plane. So we may have other protocols also for this purpose. However, for present date, open flow is the only protocol available. Now various open flow switch software. So first one is your Indigo. So this is open source and it runs on Mac OS. Then your Link, it is also open source. It runs on Linux, Solaris, Windows, Mac OS and FreeBSD. Then Pento, it runs on commercial. It turns a commercial wireless router access point to an open flow enabled switch. It runs on Open WRT. Then next one is your OFF13 soft switch. It is also it is a user space software switch based on your Ericsson Traffic Lab 1.1 soft switch. Then your OpenVS switch. It is also an open source. It is most popular one present date. Now the APIs which are used in SDN. So first API is your southbound API. So southbound API is used to communicate between your control layer and your infrastructure layer. Now control layer and infrastructure layer, basically the layer between your switches, that is your hardware, and the controller, that is your operating system. So the API which is used between your hardware and your operating system is called your southbound API, and open flow protocol is used in this API. The next one is your northbound API. So this is the API or interface which is present between your controller layer and your application layer. So the API which is present between your operating system and applications, that API is called your northbound API, and standard APIs are used for this purpose. Now east and westbound APIs. So in order to make communication possible between different controllers, we need some interfaces between them, right? So for these east westbound APIs can be used. So I have told you that this controller can be, we can use one controller also or multiple controllers also. So depending upon the need, we can have multiple controller in a network. So in order to make communication possible between those controllers, this is east westbound APIs can be used. So first problem was your rule placement. Now second is your controller placement. So controller define the flow rule according to the application specific requirement. The controller must be able to handle all the incoming requests from the switches. So rules should be placed without incurring much delay. Typically a controller can handle 200 requests in a second. So basically, so a particular controller, we need that a particular controller should be able to handle all the requests that is coming from all the switches, right? So in order to do that, we have to place the controller at a appropriate position. So that is one of the biggest challenge, that where exactly we need to place the controller and how many controller we need to place, right? The controller are logically connected to the switches in a one hop distance. However, in actual scenario, it can be away from the switches in through multi hop distance also. Physically, they are connected to a switches in a multi hop distance. If we have small number of controller for a large network, a network might be congested with control packets. So this is what I was talking about. So we need to decide that where exactly we need to place a controller and how many controller we need, so that all the requests that are coming from the switches can be handled by these controllers. Now the different architectures that are used in order to place the controllers. So first one is your flat architecture. So in case of your flat architecture, for each hardware there is one controller. So as you can see in this figure, for each hardware, for each switch, we have one controller which is going to handle all the packets of these switches. Now second one is your mesh architecture. So in case of your mesh architecture, different number of controllers can be used in order to handle the packets of different hardwares or switches. So basically, in case of your mesh architecture, different switches are interconnected with each other and further interconnected to different number of controllers, and these controllers are going to handle the packets of these switches. Third one is your tree architecture. So in case of your tree architecture, different switches are interconnected with one controller. The architecture is in the form of tree. So in this figure, as you can see, that these three switches are interconnected with this controller. This controller is going to handle all the packets of these three, or all the rules of these three switches. This controller is going to handle the rules and the packets of these two switches, and further, if required, there is one more controller which is going to handle these two controllers. So basically, in the form of tree, the hierarchy is formed. Different switches are interconnected to one controller, and that controller further can be handled by other controller. And in case of your ring architecture, different controllers are present in order to handle the flow of one particular switch. Okay, and in the form of ring, for example, at first this controller is going to handle the flow of this particular switch. After that, this controller is going to handle, then this controller, then this controller. So in the form of ring, the controllers are going to handle the flow of a particular switch, right? So in case of ring architecture, the flow of a single switch is handled by multiple controllers, and the the different controllers handle the flow in form of ring. And this ring will be logical ring. It is not a physical ring. So here in this figure, as you can see, that these controllers are arranged in the form of a ring. However, it is not always necessary that these are arranged in the form of ring only. They can be placed anywhere. Logical ring means that there should be some numbering provided to these controller, and at a particular number the control will be given to a particular controller. Now the control mechanism. So there are two types of control mechanisms that can be used in your SDN. First one is your distributed, and second one is centralized. So in case of your distributed, the control decisions can be taken in distributed manners. So in that case, different controllers are there in your network, and those different controllers are going to take the control decisions. Example, each subnetwork is controlled by different controllers. So the example of your distributed control mechanism is this mesh architecture, or your ring and tree architecture are also example of your distributed control mechanism, because different controllers are going to take decisions related to the flow. Now the centralized. In case of your centralized control mechanism, the control decisions are taken in a centralized manner. The example is a network is controlled by only a single controller. That particular single controller is going to take the flow decisions related to the flow rules, that which rule we need to place and which is not. Now the backup controller. So if a controller is down, then what will happen, right? So we need some other controller which is going to handle the request of the switches, right? So the controller which is going to handle the request of the switches, if the main controller or the primary controller is down, that particular controller is called your backup controller. So backup controller is introduced in the case if the primary controller is down. Backup controller controls the network to have uninterrupted network management. Can we consider Bluetooth connectivity between mobile phone and earphone as a form of SDN? Can you please elaborate this question? I'll try to find out. Right. Yeah. See, software defined networking means there is one controller which is going to handle the flow of the data, right? It is not. Now the security using SDN. So in case of your SDN, in order to implement security, you can use firewall, proxy, HTTP or IDS, intrusion detection system. So for example, in this network different firewalls are implemented, or different proxies and your intrusion detection systems are deployed. So you can integrate your SDN system with these in order to enhance the security of your network. Now the simulator and emulator. So in order to experiment with your SDN, we need some simulator or emulator which will replicate your actual network, right? So the infrastructure deployment must support OpenFlow. So whatever simulator emulator you are going to use, that must support OpenFlow. The controller placement should be there, and the controller placement that is there in the simulator and emulator, that also should support OpenFlow. And the controller can be remote controller can be suited at remote place and communicated using IP address and port number. So basically the controller which is placed with the help of your simulator and emulator, that controller should be able to communicate with the switches with the help of your IP addresses and port number. Now Mininet. So Mininet is used to create a virtual network with OpenFlow enabled switches. It is based on Python language and it supports remote and local controller. So basically this is a software which is used to create the virtual network with the help of your OpenFlow enabled switches. Now the controller configuration softwares of SDN. So these are various controller configuration software, for example POX, Knox, Floodlight, Open Daylight, ONOS. So these are some softwares which are available. Now the IoT architecture. So IoT architecture, I have already discussed that there is one physical layer where different sensors or actuators or your physical devices are present, then your connectivity layer with the help of which the communication can take place, then the edge computing, data accumulation, data abstraction, application, and different layers are there in your IoT architecture depending upon the architecture which is proposed by different researchers. Okay, so we need to integrate your IoT with SDN. So the benefits of integrating SDN in IoT is that intelligent routing decisions can be deployed using SDN. So in case of your IoT, as we know that yeah. Any question? Okay. Yeah, basically in case of your IoT architecture, different layers are there, right? So first one is your physical layer or your data collector layer. So basically your physical layer or data collector layer consists of different physical devices. For example, your sensors, RFIDs, actuators, which is going to collect the data or sense the data, right? Now we need to make there is a need of connection between these IoT devices. So for that, connectivity layer should be there. I am explaining this reference model. After that, I'll come to this one. Now there should be some connectivity layer also, which is going to provide connection between these physical devices, right? So the layer which is responsible for this these connections or the protocol. Yeah, actually, different researchers have proposed different architectures, right? So, depending upon their need, they have proposed different layers. So, basically, you can consider three layers. First one is your physical layer, where different devices are present. Then the communication layer, with the help of which communication is taking place, and at last the this data accumulation or application layer, where the data can be stored and further utilized by different applications. Application layer, right? And further, various researchers have divided these layers depending upon their needs also. So they have given different names to these architecture. You can read about those architecture by following their research papers. Okay. So here also these are the only layers. So they have divided these three layers into further sub layers. Uh, Screen. What are you saying, that you want the screenshot of those three layers? हाँ, यहाँ पे तो सब लेयर्स है ना. यहाँ पे फॉर एग्जांपल 7 लेयर्स आर देयर. फॉर एग्जांपल फिजिकल डिवाइस कंट्रोलर लेयर, कनेक्टिविटी लेयर, एज कंप्यूटिंग लेयर, डेटा कैमुलेशन, देन डेटा एग्रीगेशन, एप्लीकेशन लेयर, कोलेबोरेशन एंड प्रोसेस. हाँ. देखो यहाँ पे दो फिगर्स हैं, राइट. फर्स्ट फिगर है तुम्हारा लेफ्ट हैंड साइड पे. सेकंड फिगर है जिसपे कॉन्टेक्स्ट अवेयर टायर है, नेटवर्क टायर है, एप्लीकेशन टायर है. ठीक है. स्क्रीन विजिबल है मेरा? हेलो हेलो. हाँ, स्क्रीन विजिबल है, राइट. हाँ, तो यहाँ पे तुम्हारा थ्री लेयर्स आर गिवन. फर्स्ट लेयर इज योर कॉन्टेक्स्ट अवेयर टायर, जिसमें टू सब लेयर्स आर देयर. फर्स्ट वन इज योर डेटा कलेक्टर एंड सेकेंड वन इज योर कोऑर्डिनेशन एंड कोलेबोरेशन. सेकेंड इज योर. हाँ. what are you saying? Can you please repeat? ओके. हाँ. I'm not getting what are you saying. Can you please write down in chat box? हाँ. अभी सबसे पहले आई हैव डिस्कस्ड अबाउट योर SDN. अभी सेकेंड इज योर इंटीग्रेशन ऑफ योर SDN विद IoT. बट बिफोर दैट आई जस्ट वॉन्ट टू शो यू वट एग्जैक्टली इज IoT. तो उसके लिए आई हैव शोन यू डिफरेंट लेयर्स ऑफ IoT. ठीक है. फर्स्ट पेज ऑफ दिस चैप्टर मीन्स SDN का फर्स्ट पेज. हाँ, I'll share the PDF. स्क्रीनशॉट लेने का ज़रूरत नहीं है. PDF last time. Okay, I'll share the link here and I'll upload in YouTube description also. So वहाँ पे PDF होगा. हाँ, सॉरी सर, आई कांट मैसेज यू पर्सनली. मैं यहाँ पे चैट बॉक्स में तुम्हें ये दे दूँगी, लिंक दे दूँगी. यू कैन डाउनलोड द PDF फ्रॉम देयर. ओके, या, राइट राइट, दिस इज़ द फर्स्ट पेज. बेटर रहेगा पहले मैं कंप्लीट कर लेती हूँ, आफ्टर दैट, बिकॉज अदर्स आर ऑल्सो वेटिंग, राइट. या, we were discussing the benefits of integrating SDN in IoT. So first one is your intelligent routing decisions can be deployed using SDN. Second is simplification of information collection analysis. Please mute yourself. Simplification of information collection, analysis and decision making. Third is visibility of network resources. That is, network management is simplified based on user, device and application specific requirements. Fourth one is intelligent traffic pattern analysis and coordinated decisions. Now this is a diagram showing that how your different IoT devices are. Fine. Okay, so this is the figure showing that how your different IoT devices are interconnected. So basically here your physical devices are there, so these are interconnected with the help of your mobile access or fixed access. Then further your aggregation of data is done. Then this is further stored at your IoT cloud. Now we are integrating SDN with your IoT. Now we need to think that how, at which place we have to place the different components of your SDN. So this is the figure showing that at this particular anyone? Okay, I'll internet protocol. Okay, okay, I'll give 2 to 3 minutes for each and every question. I want you to go through your notes so that everyone can get to know about the answers, because otherwise I'll read out the questions and answer and everyone will not get. Okay, so I want you to go through your notes and find out the solution of each and every question yourself. So first question is in socket programming the parameter AFINET stands for Unix protocol, internet protocol, file sharing, time slicing. So someone has replied internet protocols. I want answers from others also. B. Okay. Anyone else? At least write in chat box. I'm checking chat box also. this is the topic we have covered today also and in the previous lecture also. So in socket programming, the parameter AF-INET stands for Internet Protocol. So B is the correct option. Next question is, during remote server access by Raspberry Pi, where Raspberry Pi acts as a client, the client needs the following. Options are only IP address of server, only port number, both IP address and port number. D is client's IP address. Port number. Okay, so option C. Others? So basically the option C. Okay, so basically the question is, whenever you are doing your this socket programming, so in order to establish the connection between your this server and client, you need the server's IP address, the server port address, or the server IP and port address both. So this is the question. Only 3 replies I have got. Others? Okay, so correct option is C. We need both server IP address and port number. Question number 3 is, if you are using Raspberry Pi to connect IoT sensors, which of the following Python libraries lets you configure the sensor and read the data from them? Options are Adafruit, Matplotlib, NumPy, Socket. Anyone? What? Socket? D. Okay. Anyone else? See, question is, you have to read the data from your sensors to your Raspberry Pi. So basically you should know the functionality of each of these libraries. So first one is your Adafruit, second is your Matplotlib, third one is your NumPy, fourth one is your Socket. Now, okay, Adafruit is used for your DHT sensors, right, in order to read the data from your sensor to your Raspberry Pi. So this can be an answer, because here particular sensor is not given, it's just example is given. So which one of the following? Now second is your Matplotlib. So Matplotlib cannot be used because Matplotlib is used for plotting the data, for visualizing. So it is not used for collecting the data from the sensors. So second option is incorrect. Now NumPy libraries is used for your arrays, right? So this is also incorrect. Socket is used for creating the sockets, or creating the client server program, where you need to send the data from your client to your server, right? You don't need socket in order to collect the data from your sensor to your Raspberry Pi. So socket is also incorrect. So the correct option for this case is Adafruit. So Adafruit is the library which is used by your DHT sensor in order to collect the data and transmit it to your Raspberry Pi. What? Can you please repeat? No. It is used for DHT, but here it is not mentioned that for all the sensors. For any of the in the question it is not mentioned for all the sensors. What? Digital humidity and temperature sensor. Next question is, you can store and log the different sensor data for processing in text files but not comma separated value files. Options are true, false. So question is, you can only store and log different sensor data into your text file, not in CSV file. Is this statement correct or not? B. Others? So this statement is false because you can store or log the different sensor data in either your text file or in your CSV files. Okay, it's not required that you can only store your data into your text files only. You can store in your text file also and in your CSV files also. Now next question is, consider the following Python script using split function. What will be the correct? ऑप्शन बी होगा. बी फॉल्स होगा. Next question is, so this is your Python script. Okay, using split function, what will be the correct print output? So there is a variable dat which is consisting of apple, guava, hash, banana. Now variable is dat dot split, and inside your split function this hash value is there. Now print where. So which option is correct for this? Anyone? D. Others? D is apple, guava, banana. Okay. So we are splitting using hash value. So which option is correct? In A, which? D. Okay. Others? I've got only 2 replies for this question. Okay, so here the separator is hash value, so the correct option for this is apple, guava will be in one string, and after that banana will be in the other string. So correct option for this is D. Now next question is, In SDN, the central controller defines all the paths, flows and behavior of the network in centralized manner. Options are true, false. I am repeating the question. In SDN, the central controller defines all the paths, flows and behavior of the network in a centralized manner. Options are true or false. Digital humidity and temperature. Digital humidity and temperature sensor. Okay, so okay, I have got one reply, that is A. Okay, others. In case of your SDN, central controller defines all paths, flows and behavior of network in centralized manner. Is this statement true or false? True. Anyone else? Okay, so this statement is true. So SDN is a centralized networking scheme where central controller has full global control over the network. So this statement is true. Next question is, OpenFlow is a protocol that is used for traditional distributed OSPF based networking. Options are true or false. False. Okay, others? A. A is true. OpenFlow or traditional distributed OSPF. Okay, others? I've got one A and one B. Anyone else, please? What? Is it true or false? True. Okay, others? What you are asking? Okay, OSPF expansion. So OSPF is a protocol which is open shortest path first, I guess. So it is used in your computer networks in order to transmit the data from the sender to receiver. So please check. I am not sure whether it is open shortest path first. I think it is a link state routing protocol. Please check. It is a concept of computer networks. Okay. Yeah, so it is a link state protocol which stand for open shortest path first. Okay, so the correct option for this is false, because OpenFlow is not used in traditional distributed OSPF. However, it is the concept of your SDN. Fine. So yeah, yeah. Okay. Huh. Huh. Okay. Huh. Huh. Okay. Huh. 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 So that's why this statement is false, right? So what's your question? So question is, question is, it is used in traditional distributed OSPF based networking, right? So that's what I am saying, that this statement is false. It cannot be used because the routing tables are different. Yeah, basically open flow was made for SDN, right? Where there is one centralized controller which is going to handle the flow of a whole the network. However, your this OSPF is the routing protocol which is used in your traditional networks where there is no SDN. Fine, you got my point. Basically, oh, okay, I'll reply once, and if you will not get, then I'll continue. Basically, this OSPF is a protocol which is used in your traditional networks. Basically, I have given you the diagram. Wait. Yeah, so here in this figure, that is your figure 1, OSPF can be used in order to transmit the data from your user 1 to user 2, right? Or other protocol can be used, that is your RIP protocol or any other protocol, right? So this will decide that what will be the flow and which path will be followed. Now in this case, the SDN is not in the picture, because all the nodes are going to decide or are going to follow this OSPF protocol or any other traditional protocol, that is your RIP protocol or any other protocol, in order to decide the path for sending the data. Now there is a problem in this case, that if a particular node will get attacked, then we need to make the changes in all the nodes, right? So in order to remove that problem, SDN come into picture. And when SDN come into picture, your open flow come into picture. So for your traditional OSPF protocol, there is no open flow protocol. Open flow protocol come into picture whenever your SDN come into picture, right? Yeah. So we were at question number, yeah, this question. So question number 8 is, wait. In SDN, tables in switches, in SDN, blank tables in switches describes the rules that the switch must follow for packet forwarding and are configured by the controller. Options are network, distance, hop, flow. Flow table, right? So the correct option for this is flow tables, right? Next question is, in a network architecture, one logical hop between two nodes can actually be composed of multiple physical hops in a physical network. Options are true or false. True. Anyone else? True. Yeah. So this statement is true. Next question is, what among the following is a challenge while designing SDN architecture? Options are control placement only, both rule and control placement, C is rule placement only, and fourth one is switch placement. Okay, anyone else? Right, both rule and control placement is a problem or a challenge while designing your SDN architecture. Next question is, packet in type of messages are associated with which of the following directional APIs? Option are eastbound API, southbound API, westbound API, northbound API. B. Okay, southbound API. Anyone else? Northbound API. Anyone else? Okay. So packet in messages. So the correct option for this is southbound API. because southbound APIs are the interfaces which are there between your controller and your hardware, and packet in messages are exchanged between your hardware and your controller, right? So these are associated with your southbound API. However, your northbound APIs are between your controller and your applications. In application and your controller, no packet in messages are exchanged. So the correct option for this is southbound APIs. Next question is, for an SDN switch flow rule, the soft timeout is 2 minutes and hard timeout is set to 6 minutes. After 6 minutes and 10 seconds, since the flow was initialized, what will be the status of the flow be in the switch? Options are: the flow will be surely deleted, the flow will be deleted if receives no packets for 4 minutes, the flow will remain intact, the flow will remain intact with random probability. So basically soft timeout is for 2 minutes, hard timeout for 6 minutes. After 6 minutes and 10 seconds, the flow rules was initialized. What will be the status of the flow? Anyone? B. Why? A. The flow will surely be deleted. Okay. So whoever has replied B, can you please tell me that why B? Yeah. Okay, so the hard timeout is 6 minutes, and after 6 minutes 10 seconds the flow will surely be deleted, because hard out time out means after that particular time the switch will be reset. So A is the correct option. Next question is, it is a good idea to keep a backup controller in SDN architecture along with the main controller. Options are true or false. True. Okay, anyone else? True. Right. Next question is, software defined IoT solves the challenges of blank that is relevant in traditional IoT networks. Options are uniformity, deployment, homogeneity, heterogeneity. Heterogeneity. Okay, anyone else? Heterogeneity. Okay, yeah, so heterogeneity is the correct option. Next question is, sensor open flow, soft WSN and SDN wise are the examples of. Options are traditional routing protocols, various SDN protocols for wired LANs, various implementations of the concept of software defined IoT, traditional IoT protocol examples. C. Okay, anyone else? Okay, I'll share the link with you after the questions. Anyone else? Okay, so the correct option for this is C, that these are the various implementations of the concept of SDN IoT. Next question is, you have an IoT temperature sensor that is sensing temperature from a particular location and sending the data over the network to a server situated far away in another city for storage. This is the example of remote data logging. Options are true or false. Why? What is remote data logging? Anyone? What is remote data logging? True. Okay. Can you please explain what is remote data logging? Yeah, right. So basically in this question it is said that you are collecting data at a particular location and sending that data to another city. So this is example of your remote data logging. So the option is true. Next question is, for a two-way communication between a client and server, that is both the client and the server send data to each other, it is important that both of them knows about following of each other. Only the IP address of the server, only the port number of the client, both IP address and port number of each other, neither the IP address nor the port number of each other. Right. So C is the correct option for this. Next question is, if you are using what? Yeah. Hmm. Hmm. Okay. See, what is software defined network? Because from this question, what I feel is your concept related to SDN is not clear. So, what do you understand by SDN? Yeah. And what is the purpose of your SDN? No, the purpose of your SDN is to maintain the flow of the data packets. Okay. So basically here the question is two-way communication between your client and server. So basically we have two devices, client and server, which are communicating with each other, right? Now in order to transmit the data, we want to transmit the data from the client to server and server to client. Now in between your client and server there are various routers, various switches, right, various gateways. Fine. So in order to control those intermediate devices, if we are using a technique where there is a central controller, then it is a SDN. We are adopting SDN architecture there, right? But sender and receiver will remain intact. So in order to make the communication between sender and receiver, we need both the IP address and port number of each sender and receiver. The aim of your SDN is just to control the network, the intermediate network. So if you are using SDN or if you are not using SDN, it doesn't matter. For making the communication possible between two devices, that is your client or server or sender or receiver, you need IP and port number both. Fine. हाँ. Right. Basically here it is mentioned that there is a client and server. So client and server means you are using socket programming. Fine. हाँ. Why? Can you please explain? What can you repeat? Hmm. Hmm. Right, right. It's not related to Python programming only. Whenever you are using socket programming in any language. Yeah. Right, right, right. Yeah, yeah. Huh. Huh. Yeah. Why? So, see, SDN, that is responsible for control, making the connection possible between your controller and your hardware devices which are further sending the data. See, basically, and that you are saying that some of your SDN controller are not using IPv6, right? They are using ZigBee. So that is responsible for making the connection between your controller and your hardware devices which are just forwarding the data. That is also a network, but data transfer here, we are sending the data from a particular sender to a receiver. We are talking about the data packets, not the control packets which are exchanged between your controller and your hardware devices which are responsible for just forwarding the data. Here we are talking about two particular nodes or two particular client and server which are sending the data. Basically, I'll show you with an example figure. Here, see, this is user 1 and this is user 2. So here consider this user 1 as client and this user 2 as a server. Fine. We are sending the data between these two, client and server. Now SDN comes into picture. Consider that here is one controller node. Fine. Which is controlling these devices, these intermediate devices. So whatever you are saying that we can use ZigBee, so that ZigBee is used in order to make the communication possible between that controller and these intermediate devices. However, the question is about these two devices, that is your user 1 and user 2. So for those two users, they need to know about each other's identity, right? That's why they can send data. Without identity, how they can send data? Huh. Both of them can be heterogeneous or they can be homogeneous. It is not about that thing. Okay. So how they can send data? Can you please elaborate? Because no, because in this case, because we need some identity, otherwise how you can send data? Because if you don't have the address of other person, how you can send the data to that particular person, right? Which is present in some other network. So you need some IP address or port number in order to reach that particular network. And SDN comes into role in just to maintain these intermediate devices. SDN has nothing to do with this user 1 and user 2. SDN is just maintaining the flow, just maintaining the paths. It's not maintaining the IP addresses. Yeah. So this the ZigBee thing, what you was saying, this is used to make the connection between your hardware devices, that is your intermediate devices, and your controller. However, between your server and client, you have to use socket programming in order to exchange the data, right? Either socket programming, or you can directly establish the connection with the help of wires. That is different case. Okay. Next question is, if you are using Raspberry Pi if you are using Raspberry Pi to connect standard IoT sensors, which among the following components of Raspberry Pi do you use to connect your Raspberry Pi to your sensor for data transfer? Options are HDMI port of your Raspberry Pi, micro SD card slot for RPi, Ethernet LAN port of RPi, then general purpose input output pins of your RPi. Anyone? GPIO. Okay. Others? D. GPIO. Anyone else? So correct option for this is GPIO. Next question is, it is possible to connect a single DHT temperature sensor with a suitable number of connection wires with two Raspberry Pis acting as a client for same sensor. Options are true or false. So basically question is whether you can connect one sensor with multiple Raspberry Pis or not. Two Raspberry Pis which can act as a client for same sensor. So is it possible or not? A. Okay, anyone else? The correct option for this is A, that is true. So you can make multiple connections. Next question is, which among the following denotes the correct connection order for a standard 4-pin DHT sensor with the order of pin numbers taken as 4, 3, 2, 1? So basically you have to tell that pin 4 is related to what, pin 3 related to what, pin 2, and pin 1. So which of these options are correct? Okay, so pin 4 of DHT sensors implies what? Anyone? Pin 4. We have discussed this thing many times. Okay, C. So basically you are saying pin 4 is ground, then pin 3 is null, pin 2 is data, and pin 1 is power. Fine. Yeah, so this is correct. So basically pin 4 is your ground, pin 3 is null, pin 2 is data, and pin 1 is power. Next question is, using the matplotlib library in Python, you are plotting a graph of pressure value versus time, with pressure taken in vertical axis and time taken in horizontal axis. While writing the code to plot the graph, which among the following is correct parameter that you can write within the function y level? So inside y level, what you are going to place? Time, pressure, length, mass. So basically vertical axis mean pressure, horizontal mean your time. So y label, inside your y label, what you are going to place? Time, pressure, length, mass. pressure. Yeah, so pressure is correct option, because vertical mean along your y-axis, so along your y-axis it's pressure, and along your x-axis it's time. So correct option for this is pressure. Next question is, lack of centralized controller is a problem and limitation of traditional network architecture without SDN support. This statement is true or false? True. Okay, anyone else? B, false. So this statement is true. Basically, in case of your traditional networks, we don't have centralized controller, right? So that is a problem, because since we don't have centralized controller, we have to make changes in your all nodes which are present in your network. So that is one of the major limitation that is there in your conventional network architectures, and which is solved by your SDN by making the use of centralized controller. So this statement is true. Lack of centralized control. So basically there is no see, no, we don't have. How? See, only Unix system, basically we are considering the network, traditional network architecture, where we have different nodes present in the network. There is no centralized control over those networks. So if one particular nodes fail, we have to make changes in all the systems. If there is a, yeah, see, if a particular topology you are talking about, then it is different thing, but in actual scenario, in actual yeah, yeah, but okay, yeah, yeah, that, yeah, but if that particular one single in case of your bus topology, if that particular bus will go down, then you have to make changes that huh, bus. See, but in actual network scenario, in it is not always required that you are using only bus topology or you are using only a star topology. Network is a combination of different topologies, right? Computers can be connected in any, basically mesh topology is the only topology that is used in actual network scenario. Fine. Hmm. But you have to make changes in all the nodes. See, if a particular node will go down, and if that node is present in the path through which the packets are transmitting, then you have to make the changes in all the nodes, right? That is what we have talked. See, why there is a need, see why there is a need of SDN. So in the starting of this lecture only, I have talked about that there is a problem of that there is no centralized control in case of your traditional network, due to which we need something called SDN. So that was the only problem, right? So hmm, hmm. See, this thing, okay, agree, लेकिन one point is there, there is no centralized control in traditional network. One of the point is that, right? I am not talking about other limitation. This question is only talking about that there is a lack of centralized control in traditional network, and this is one of the challenge. This is the question. Hmm. See, I'm not talking about the other systems will go down. The question is not related to if one system goes down, then other systems will also go down. The question is if one particular system will go down and that particular system lies in the path between your sender and receiver, then we have to make changes in all other nodes, because there is no centralized control. If there is a centralized control, then we only need to make changes at the centralized controller only. But however, in your traditional network there is no centralized control. We have to make changes in other nodes also. I'm not saying that the system will go down. I'm saying that we have to make changes in other nodes also, so that that particular path we should the sender will not follow that particular path. Fine. See, the question I have not formed this question. This is the question which I have taken from the previous assignment. So this is the question what was given there, and this question means that if if there is no central since there is lack of centralized control in traditional network without SDN, so is it a problem or not? So that was a problem, because if there is no centralized controller, we have to make changes in all the nodes. Fine. Got my point. Next question is detaching the physical hardware from the overlying software components such as operating system and the application forms an important aspect of transitioning to SDN. Options are true or false. Anyone? So the correct option for this is true. Next question is flow rules are stored within SDN switches that run the open flow protocol in the following format. Options are images, files, tables, none of these. Tables. Anyone else? Yeah, okay. Yeah, so the correct option for this is tables. Next question is among the following, which is the most unlikely to be considered as a suitable candidate for a match field for flow rules in SDN? Options are source port number of the packet, destination IP address of the packet, temperature of the switch motherboard, destination MAC address. Anyone? C. D. Okay, so do you require the temperature of switch motherboard inside your flow table? You are saying कि destination MAC address is most unlikely to be considered. So I am saying कि temperature of the switch motherboard we should consider this field. So most unlikely should be C, right? Temperature of the switch motherboard. Next question is in SDN, the central controller of one network can communicate with the central controller with another SDN network through which of the following directional APIs? Option are east-west bound APIs, southbound APIs, westbound APIs, none of these. Right. So east-west bond, right? East-west bond APIs are used in order to make the communication between different central controllers. Next question is, suppose in SDN there are two switches S1 and S2. The same packet P arrives in both the switches. S2 does not have the appropriate flow rule to forward this particular packet, where S1 has. Then with respect to two switches, what is the correct action that is taken? S1 sends packet in to the controller, S2 forwards the packet. S2 sends packet in to controller, S1 forwards the packet. Both S1 and S2 sends the packet in to the controller. Both S1 and S2 forward the packet. Anyone? S2 does not have flow rule. A. Why? No. See, basically what happened is, S1 is a switch which has the flow rule and S2 does not have. So S1 has the flow rule, it has the information that how to forward the packet. So it will directly forward the packet to S2. Now S2 does not have any information or flow rule related to the flow of that packet. So it will send the packet in information to the controller so that it can get the information about the flow from the controller. So S2 sends the packet in to the controller and S1 sends the packet. So correct option is B. Fine. Next question is, no matter how big an SDN network becomes, we can never have more than one SDN controller. Options are true or false. False. Yes. Yeah, false. Next question is, with software defined IoT, it is possible to control the individual physical sensor and actuators node as well as rule placement of the backbone network remotely by suitable orchestration and software. Options are yes or no. Anyone? Yes. Anyone else? Okay. Backbone network is the main network through which the data exchange can take place, the intermediate network. Yeah. Or the transport network. Yeah. What? Your voice is breaking. Orchestrations mean the automation of the network, that how the exchange of data can take place. Although automation, you can consider the word automation. Okay. Next question is, soft WSN that has been proposed as one of the solution to software defined IoT achieves the following. Options are only device management, only topology management, both device and topology management, neither device nor topology management. Soft WSN that has been proposed as one of the solution to software defined IoT achieves the device management, topology management, both device and topology management, neither device and topology management. So the correct option for this is both device and topology management. So soft WSN was proposed in order to manage both devices and topologies. So you can follow on this paper so in order to get more idea about this soft WSN. So these were the questions of week 7. And if you have any question, okay, it's already 8:10. If you have any question, then please ask, otherwise I am going to terminate the session. You can ask. I'll give you the answer in the next session. Yeah. Yeah, it will be better. um, I'll paste this question in the notepad and answer you later. Okay, link of the previous session. Okay, wait. Last week we didn't have any session, but this is a link which is for previous, okay, last to last week. So I have given the link of YouTube. You can go through that. Okay. Okay, then I am terminating the session. Okay. Okay, thank you.